Hello everyone, welcome to my vlog, and in this video we are going to talk about illustrating polynomial function. And in this topic we are going to have two parts. So first part would be discussing about degree, leading coefficient, standard form, and transforming polynomial function in its standard form. And then the second part is understanding the polynomial function graph. And are you ready? So let's go to our first part, and to begin with, I have here an activity. So from the following given, which do you think is a polynomial function? Is it A, f of x is equals to x cubed minus 4x squared plus 6, b, y is equals to the quantity of x plus 1 times the quantity of x minus 2 times the quantity of x minus 3, letter C, p of x is equals to negative x squared times the quantity of x plus 3 times the quantity of x minus 1 squared. Letter D, y is equals to 2x cubed over 3 plus 5 third minus 15x. And lastly, E, f of x is equals to x to the power of negative 3 minus 4 over 2x plus 6 square root of x minus 2x. So which do you think is a polynomial function? Is it A, B, C, or D, or E? Okay, so if your answer is letter A, then you are correct. And if your answer is also letter B, you are also correct. And if your answer is letter C, you are still correct. And letter D, you are absolutely correct. And for letter E, if your answer is letter E, then we have a problem. Why? Let's take this one. Why is it that this one is not a polynomial function? First reason is because it has a negative exponent. No? So when you have a negative exponent, that is not a polynomial function. Negative exponent of the variable. So when you have a negative exponent of a variable, then that is not a polynomial function. Second, make sure that you don't have a square root of x. Why? Because a square root means a fractional exponent. No? So square root is to the power of 1/2. So if you have an exponent that is a fraction, so that is a sign that it is not a polynomial function. Another thing is having a denominator of a variable. Having a denominator of a variable. A variable denominator. Okay? So that is also not good sign of a polynomial function. Why? Because a polynomial function only has a non-negative exponent of its variable. Second, a polynomial function does not have a fractional exponent. And third, a polynomial function does not have a variable that is a denominator with a whole number as numerator. Okay, so these are the signs of a polynomial function. And aside from that, a polynomial function has what we call degree, coefficient, and standard form. So what do we mean by degree, coefficient, and standard form? So let's take letter A as an example. Okay, by the way, how to write a polynomial function? So you can have f of x, or you can have y or p of x is equals to, and so on and so forth. So going back, what do we mean by degree? So in this example, f of x is equals to x cubed minus 4x squared plus 6. The degree is equal to, the degree is actually 3. No? Why 3? Because it is the highest exponent. So when you say degree, it means the highest exponent of the variable. So that's degree. And when we say coefficients, these are the numbers beside the variable. No? The numbers beside the variable. So in this case, the coefficients are the number beside the variable. Okay, so that's coefficient. And for this one, the coefficient is actually 1. Okay, so when you only see a variable and it doesn't have a number beside it, it means that the coefficient is equal to 1. Okay, and in here, for the second term, the coefficient is equal to, what do you think? It is 4. Okay, why 4? Because it is beside the number beside x. And how do we call the number without a variable? It is actually called constant term. Okay, so again, degree is the highest exponent, coefficient is the number beside the variable, and then the constant term is the number without a variable. And if ever you see a variable without a number beside it, it means the coefficient is equals to 1. Okay, and what do we mean by standard form? Actually, our example here, f of x is equals to x cubed minus 4x squared plus 6, is already in standard form. Why? Because when we say standard form, it means that the terms of the function are arranged in decreasing exponent of the variable. Okay, so when we say decreasing, it is from highest exponent to the lowest exponent of the variable, no? Okay, so when we say standard form, it is from highest exponent to the lowest exponent. Okay, so here from left to right. Okay, so from here to here. Okay, so again, in standard form, the terms, when we say terms, these are one term, another term, and another term. It is separated by either a minus or a plus. So that's how to identify terms. And there are, in this example, we have 3 terms. 1, 2, 3. Okay, so that's about standard form and getting to know polynomial function. And if we try to go back to our topic, actually we have the last part, transforming polynomial function in its standard form. So we have already discussed, no, the standard form. So what if our function is not in standard form? Do you think B, C, and D are in standard form? I don't think so. So we have to make B as a standard form. So how to transform? Now let's go to transforming polynomial function in its standard form. So why is it important to transform polynomial function in its standard form? So that we can easily identify the degree and its leading coefficient and its constant term, because we are going to use them in our succeeding topics. So now, how are we going to transform? Actually, in this given example that we have, that's y is equals to the quantity of x plus 1 times the quantity of x minus 2 times the quantity of x minus 3. This is actually in factored form. This is actually in factored form. When we say factored form, that's how it looks like. Factored form, no? So two standard forms. So no, first multiply. Let's perform FOIL. No, and it is for these two. So x plus 1 times x times x minus 2. Okay, so first term to first term, that is x squared. Next is first term to the outside to outside. So x times negative 2, since it has minus, so x minus times negative 2, that's negative 2x. Next is the inner x plus positive 1 times positive x, so that's positive x, and 1 times negative 2, that is negative 2. Now combine like terms. So negative 2x and plus x are like terms because they have the same variable and they have the same exponent of the variable, which is 1. So let's copy the unaffected x squared. Then negative 2x plus x, that's negative 1x or negative x minus 2. Now, let's continue doing FOIL for the last factor. Okay. So, x times x is equals to x cubed. X squared times x is equals to x cubed. You add the exponent when you multiply. Next is x times negative 3. X squared times negative 3, that's 3x squared. Next is negative x times x is equals to negative x squared. Next is negative x times negative 3, so that's positive 3x. And then the last one, that is negative 2. So negative 2 times x, so that is negative 2x, negative 2x, negative 2 times 3, so that's negative or positive 6. Then combine like terms. So we have here and also this one. Okay, so let's combine them. Okay, so the answer is x cubed, negative 3x, negative 2x, so that's negative 4x squared. Okay, plus positive 3x minus 2x, that's positive 1x or x, plus 6. Okay, so this is now our standard form. Y is equals to x cubed minus 4x squared plus x plus 6. So what is our degree? What is our degree? Our degree is, the degree is equals to 3. How about our leading coefficient? When we say leading coefficient, the coefficient of the variable having the degree. So the first coefficient. So since this is our first term and the first coefficient here is invisible 1. So our coefficient is equal to 1. Okay? Our coefficient, leading coefficient is equals to our leading coefficient is equals to 1, and then our constant term is equals to positive 6. Okay, so that's how you transform the given function from factored form into standard form for us to identify easier our degree, which is the highest exponent, the leading coefficient, which is the coefficient with the variable having the highest exponent, and the constant term, which is the number or the term without a variable. Okay, but if you have difficulty, difficulty determining or doing FOIL, but it's very necessary to do that, we can actually identify degree by just, for example, let's get this example again. So how are we going to get the degree without doing FOIL? So in getting the degree, we will just count, no? How many x are there that you're going to multiply? So there are 1, 2, 3. So it means our degree is equals to, 3 because there are 3 x's. Next, for the leading coefficient, we are going to look for the coefficient of x. So here, what's the coefficient? 1. Here, what's the coefficient? 1. Here, what's the coefficient? 1. Then we are going to multiply them. So 1 times 1 is 1. 1 times 1 is 1. Therefore, our leading coefficient is equals to 1. Okay. Our leading coefficient is equals to 1. Next, our constant term. How are we going to get our constant term? So, to get the constant term right away, we are just going to determine the constants for each factor. So what's the constant here? That's positive 1. What's the constant here? That's negative 2. What's the constant here? That's negative 3. Don't forget the sign. So 1 times negative 2, that's negative 2. Then negative 2 times negative 3, that's positive 6. Therefore, our constant term is 6. No? So you can determine them without doing the entire multiplication. Okay? So that's how are you going to do it. So let's try another example. Let's take this, okay? So let us determine the degree. What do you think is the degree? So let's count the x. So since this is x squared, there are how many factors? 1. There are how many factors? 1, 2, 3. So let's count. Okay, let's count how many x. So since this is squared, so there are 2 x's. How about here? Only 1. And here it's 1, but as you can see, there is an exponent. So it means there will be 2. So all in all, that's how many? 2 plus 1 plus 2 is equals to 5. Okay, so our degree is 5. We are just counting how many x, no? So to get the degree, just count how many x. Count how many variable x to get the degree. Next, how are we going to get the leading coefficient? To get the leading coefficient, get the coefficients of all the factors. Here, it's negative 1. The coefficient here is positive 1. The coefficient here is positive 1. So negative 1 times 1, that's negative 1. Negative 1 times 1, that's negative 1. So that's why. Okay? So again, to get the leading coefficient, get the coefficients of x and multiply. Okay, ala. Okay, so and to get the constant term, we are going to multiply all the constant. So in here, is there constant? No constant. Here there is a constant. which is 3. Constant is 3. Here is negative 1. No? So since there is no constant here, the constant here is 0, right? So if you multiply the numbers with 0, the answer is 0. So therefore, our constant term is 0. There's no constant term. Okay, get all the constant in the factors and multiply. Oh my gosh. So that's how you get it. So now we have our degree, leading coefficient, and constant term without even doing the long multiplication process. Okay, now let's go to the last example that we have. This is letter D. So what do you think is, oh, first, is this already in standard form, and is it in factored form? It is not in factored form, so we cannot do our previously done steps. So all we need to do, if it's already in this case, all we need to do is just arrange them. Okay, so let's inspect what is the highest exponent. The highest exponent is 3. So the terms having the exponent 3 will be written first. So 2x cubed over 3. Next is, there's no 2, but we have here 1. Diba? So it's invisible 1. So 15x. And lastly is the constant term, 5/3 or 5 over 3. So this is now our polynomial function in standard form. So what's our degree? That is the highest exponent, which is 3. Okay? It is 3. Our leading coefficient is equals to yes, this is our leading coefficient, the number beside the term having the number beside the variable having the highest exponent, and that is 2/3. And our constant term is equals to 5/3. The term without a variable. This one. Okay? So do you have any question? That's all for our topic. The first part of our topic, illustrating polynomial function, knowing the degree, leading coefficient, standard form, and transforming polynomial function in its standard form, and determining what's the degree, leading coefficient, and standard form in factored form, and also in a disarranged polynomial function. Okay, so do you have any questions? Comment down below, and I hope this video have helped you, though it's very long, but you have to listen. I trust. Okay, so again, a polynomial function must be a non-negative must have a non-negative exponent of all its variable, and does not have a fractional exponent, and does not have a variable that is a denominator with a whole number as numerator. Does not have a variable that is a denominator with a whole number as a numerator. Okay, So fractional, it has like cube root, square root, in that one, or the fraction itself. Okay. Okay, so that's all. Bye bye. Love lots. Anyway, if you are new to my channel, please share and subscribe. Please, please, please. I do need your help. Thank you. Bye bye.